The role of waves in energy transfer. To understand the role of waves in energy transfer, we can carry out this simple activity. Place some dominoes to form a line of equal distance from each other, then push the first piece. When the first domino piece fell, its energy transferred to the next one. That falls down in turn, transferring the energy to the next piece, and so on. Energy transfer through the domino pieces continues, and the pieces never change position in the line. So, the wave is the disturbance that propagates and transfers energy in the direction of propagation. Types of waves. Waves can be classified in two ways. 1. According to the direction of vibration of medium particles relative to the direction of propagation into A. Transverse waves, B. Longitudinal waves. 2. According to the ability to propagate and transfer energy into A. Mechanical waves, B. Electromagnetic waves. First, the transverse and longitudinal waves. In the transverse wave, the direction of particle vibration is perpendicular to the direction of wave propagation. In the longitudinal wave, the direction of particle vibration is parallel to the direction of wave propagation. The transverse wave can be represented by this graph. The highest point called crest, and the lowest point called trough, while longitudinal wave can be represented by this figure. The point of highest density and pressure is called compression, and the point of lowest density and pressure is called rarefaction. Applications for wave motion. Physiotherapy tubs or the jacuzzi. Jacuzzi is a tub where water moves in the form of circular waves. It's used to treat sprains and cramps when used with hot water and nervous tension when used with cold water. Mechanical and electromagnetic waves. Mechanical wave. It needs media to travel through. It is slow wave compared to the electromagnetic wave. It could be transverse wave like water wave or longitudinal wave like sound wave. Electromagnetic wave. It needs no media to travel through. It is fast. It is transverse wave only, like light waves and radio waves. Concepts related to wave motion. 1. Wavelength. It is the distance between the centers of two consecutive compressions or rarefactions, or two consecutive crests and troughs. 2. Amplitude. It is the maximum displacement achieved by the particles of the medium away from their points of rest. 3. Wave velocity. It is the distance covered by the wave in 1 second. Velocity v equals distance covered by the wave in meters m over time in seconds s. The velocity of a given wave is constant as it travels through the same medium. However, it differs as the nature of the medium changes. For example, the sound velocity in air differs from sound velocity in water, differs from sound velocity through solids. 4. Frequency. It is the number of complete vibrations made by the vibrating particle in 1 second. the law of wave propagation. This law is a relation between wave velocity v, wave frequency f, and wave length, lambda. We know that the wave velocity is the distance covered in 1 second, and as shown in the figure, the distance traveled by the wave in 1 second contains 4 waves. That is the frequency, which is the number of waves made in 1 second. So, we can say that wave velocity equals frequency times wavelength.